Electric power generation is a foundational component of modern civilization. It involves converting various forms of energy into electrical energy through a process that utilizes power plants, generators, and numerous supporting systems. This video provides an in-depth exploration of electric power generation, including types of power plants, classifications by fuel and prime mover, and key generator components. Electric power generation involves transforming primary energy sources such as fossil fuels, nuclear fuel, and renewables into electricity. This electricity is then transmitted and distributed to consumers for residential, commercial, and industrial use. The importance of electric power generation cannot be overstated, as it is the backbone of modern infrastructure, powering everything from homes and hospitals to industries and transportation systems. Efficient generation methods and stable supply are crucial for economic development, technological progress, and national security. Classification of power plants are facilities designed to convert primary energy into electricity. They can be classified based on the type of fuel used, e.g., coal, nuclear, solar, or the prime mover mechanism employed, e.g., turbine, engine. This classification helps in understanding the source, method, efficiency, environmental impact, and application of the power plant. Classification by fuel type: fossil fuel power plants, comprising coal, oil, and natural gas plants, are the most widespread. Coal-fired power plants dominate in countries with abundant coal reserves. They work by pulverizing coal and burning it in a furnace to heat water in a boiler. The resulting steam drives a steam turbine connected to a generator. Despite high emissions, modern technologies such as fluidized bed combustion and flue gas desulfurization have improved their efficiency and reduced pollutants. Oil-fired plants use heavy fuel oil or diesel. They are often used as peaking or backup units due to higher operational costs and dependency on oil imports. These plants offer fast startup but suffer from lower efficiency and higher emissions. Natural gas plants are considered cleaner and more efficient. In simple cycle plants, natural gas is combusted directly in a gas turbine. In combined cycle gas turbine (CCGT) plants, exhaust gases from the gas turbine are used to produce steam for a steam turbine, significantly boosting overall plant efficiency. Nuclear power plants use enriched uranium or plutonium as fuel. The nuclear fission process releases heat used to convert water into steam, which drives a turbine. These plants offer high energy output, low greenhouse gas emissions, and base load reliability. However, they involve complex safety measures, long construction times, and radioactive waste management. Renewable energy plants use sustainable resources. Hydropower plants use flowing water. Wind farms use wind turbines. Solar plants use photovoltaic cells or solar thermal collectors. Biomass plants use organic material, and geothermal plants use Earth's internal heat. These are environmentally friendly but often intermittent and location-dependent. Classification by prime mover: the prime mover is the component that converts thermal, kinetic, or hydraulic energy into mechanical rotation to drive a generator. Steam turbines are used in thermal coal, oil, nuclear, biomass, and some solar thermal plants. They require high-pressure steam and operate at high efficiencies when paired with regenerative or reheat cycles. These turbines are robust, reliable, and scalable. Gas turbines operate on the Brayton cycle. They are compact, capable of fast startup, and widely used in peaking plants and aircraft. In power generation, they are often combined with steam turbines in CCGT configurations for enhanced efficiency. Hydraulic turbines include Pelton, Francis, and Kaplan types, each suited to different head and flow conditions. These turbines convert the potential and kinetic energy of water into mechanical energy, which is ideal for both base load and peak load applications depending on reservoir capacity. Wind turbines use rotor blades connected to a gearbox and generator. Their output varies with wind speed. Modern wind turbines feature pitch and yaw control for performance optimization and grid stability. Internal combustion engines, diesel or gas, are used in small-scale or distributed generation, emergency backup, and isolated grids. They offer quick response and ease of installation but are less efficient and have higher maintenance needs. Nuclear power generation is based on controlled nuclear fission. Uranium-235 and plutonium-239 are common fuels. In a reactor core, fuel rods undergo fission, releasing neutrons and energy. Control rods made of cadmium, boron, or hafnium absorb excess neutrons, maintaining criticality. The heat from fission is transferred to a primary coolant. In pressurized water reactors (PWRs), the primary loop heats water under pressure, preventing boiling. This transfers heat to a secondary loop via a heat exchanger steam generator. In boiling water reactors (BWRs), water boils directly in the reactor core to produce steam. Advanced reactors include fast breeder reactors, which produce more fissile material than they consume, and small modular reactors (SMRs), which offer scalable, safer solutions. Nuclear plants require strict safety systems, redundant cooling, containment buildings, emergency shutdown systems (SCRAM), and monitoring systems. Spent fuel is stored in cooling pools and then transferred to dry casks or reprocessed. Despite high initial investment and social concerns, nuclear plants offer stable, low-emission, high-capacity electricity ideal for long-term energy security. Fossil fuel power generation, coal power generation involves complex processes, fuel handling, combustion, flue gas treatment, ash handling, and waste heat recovery. Supercritical and ultra-supercritical boilers operate at high pressure and temperature for better efficiency. Natural gas plants are favored for their flexibility and reduced emissions. In open-cycle gas turbines, the thermal efficiency is lower 35%, but in combined cycle operations, it can exceed 60%. Environmental control systems include electrostatic precipitators, baghouse filters, flue gas desulfurization (FGD), selective catalytic reduction (SCR), and carbon capture and storage (CCS). Economic factors, fuel price volatility, and decarbonization policies affect the long-term viability of fossil fuel plants. Transitioning to cleaner technologies and retrofitting older plants is critical for meeting emission targets. Hydropower generation. Hydroelectric plants use dams to create reservoirs, controlling the release of water to generate electricity. The plant consists of intake structures, penstocks, turbines, generators, and tail races. Control gates regulate flow, and surge tanks mitigate water hammer effects. Francis turbines are used for medium head and flow. Pelton turbines are for high head, low flow sites. Kaplan turbines are adjustable and suited for low head, high flow rivers. Pumped storage plants serve as giant batteries. During low demand, surplus power pumps water to an upper reservoir. During peak demand, water is released to generate electricity, aiding grid stability and frequency regulation. Environmental concerns include fish migration, sedimentation, and ecological changes.